So we're now going to see how the Schwarzschild transformation works in the case of what's pretty much one of the simplest closed polygons, a triangle, in this case a right-angled triangle. So the integral, the problem we're going to get is the integral. The integral is rather difficult. In fact, it can only be solved in terms of some exotic special functions. But we'll just leave the answer in terms of the integral anyway. But nevertheless, we'll try and keep things as simple as possible. Okay, so we start off with our formula. So w equals w naught plus the integral from z naught. And then we're going to have two points we can see on the x-axis. The third point, x3, will be at infinity. Okay, so we're going to try choosing x1 to be here, and just to keep things simple, we'll put x2 as equal to 1. So what we want is, it would seem simplest if we map x1 to the origin in w plane. So this is going to be our w1, and x2 is going to get mapped to w2 here, and infinity is going to get mapped to w3 here. Just as a check, as you go from x1 to x2, the region you want is on the left, w1 to w2, the region you want is on the left. Okay, so choosing x1 to equal 0 actually helps us a little bit, because it allows us to choose z0 to be 0. Basically, we want this transformation to map 0 to 0. So we know that f of 0, x1, should equal w1, which is 0. So for this to happen, if z is 0, and z0 is 0, and w0 is 0, then this will work. So we can actually get rid of, we can make w0 equal to 0, and we can make z0 equal to 0, and this simplifies things a little bit. I forgot to put the alpha here. So we've got that so far. Now we've defined which is x1 and which is x2, we can actually put things in. So we've got so we've got the formula is x1 minus minus z to the x1 minus z to the minus p1. So p1 in this case is the angle at w1. So the angle at w1 is the angle that I turn as I go from w1 to w2. So the exterior angle here is 90 degrees. So that's 90 degrees, that's pi by 2, divided by pi is 1 minus a half, so it's minus p1. Then as we go from here, when we reach w2, as we go from here to here, we have to turn through an angle of pi minus psi. Okay, so this angle here is pi minus psi, and then divide that by pi. We end up with okay, and then we're done. Sorry, I got the z's. Yeah, for some reason I was thinking the other way around. So it should be z minus 1. Okay. Right, so it actually helps us to do these integrals. If to put the integral in standard form, we're actually going to reverse the z and the 1, which will give us some complex factor. So that complex factor we don't really care about. It's going to be absorbed into alpha, so we just have to change the name of alpha. So I'm going to rewrite the integral, reversing this and saying whatever happens when I do minus 1 to the power of this factor, I'm going to put inside alpha and call it a new name. Okay, so this is little z. This is just sort of a cosmetic change to make the integral look nicer and be recognizable as a, and then obviously I can change this to psi over pi minus 1. Okay. So far we have used the fact that x1 gets mapped to w1. Next we can use the fact that x2 gets mapped to w2. So that basically means that 1 is equal to f of 1. So substituting that in, we've got 1 equals alpha dashed, and then z is equal to 1, here 1. Sorry, dz. Now this happens to be a known integral. So it turns out that this can be written in terms of what's known as the beta function. If you haven't seen the beta function before, then don't worry too much. But this, okay, well just to give you a definition of the beta function. So the beta function mn, there's actually many different definitions, but one definition is t to the power m minus 1 times 1 minus t to the power n minus 1 dt is equal to bmn. So in this case, m minus 1 is equal to minus a half, which means m is a half, and n is psi over pi. So that means that we can write alpha prime now as 1 over beta of half, comma psi over pi. And that's really sort of as far as we can get. And then we can obviously substitute this back into here, and we've got our transformation w equals this. But then we somehow need to evaluate this integral. So this integral, I think, is where you've got z here instead of 1, can be written in terms of something called the incomplete beta function, but it's a somewhat exotic special function. And that's really as far as we can get.